Good morning, students. In previous classes, we see the scheduling, concurrent scheduling in transaction management. Now, today we discuss about the lock, that is locking protocol in concurrency control. Lock is basically a variable that associated with a data item that describes the status of the item with respect to possible operation that can be applied to it. The basic lock is binary lock. In binary lock, there have two states. One is locked, that will be 1, or unlocked, that will be 0. Now, how we define the binary lock, there will be some specific rules. A transaction T must issue the operation lock item. That means the lock for a particular, when it will be read or write on a particular item X. Second, a transaction T must issue the operation unlock item for the item X when all the read item and the write item operation of X will be over. A transaction T will not issue a lock item X if it already holds the lock on the item X by another transaction. A transaction T will not issue the unlock item until it holds the lock item. So these are the basic rules for defining the binary lock. That means whenever we want to read or write any items, the transaction raise the lock operation, and whenever complete all the read and write for the particular item X, the transaction issue the unlock operation. So in binary lock there will be some disadvantage. What is that disadvantage? This locking system is restrictive for database items because at most one transaction can hold a lock and lock in a particular time. That means concurrency is not there. If two transactions access the same data item, then it will be not possible in the binary lock. And thus binary lock is not applicable in our practical purpose or real life example. Now we discuss about the next uh, lock method, that will be known as shared exclusive lock or read write locks. To overcome the drawbacks of binary locking, there will be another multiple lock mode that will be known as shared or exclusive lock or read write lock. In this locking system, there are three more operations. One is read operation, read lock operation, one is write lock operation, another is unlock operation. Read lock item or read lock operation is known as shared lock, and write lock operation is known as exclusive lock. And whenever we define shared for S and exclusive for X. Now there are some specific rules for shared or exclusive lock. A transaction T must issue the operation read lock or write lock before any read item or before any read item operation is performed in T. That means before any read operation, the transaction must issue the read lock or write lock option. Second, a transaction T must issue the operation write lock before any write item. That means before any write operation, the transaction T must issue the write lock mode. A transaction T must issue the operation unlock after all read and write operation is completed. A transaction T will not issue a read lock operation if it already holds a read or shared lock or a write or exclusive lock on item X. A transaction T will not issue a write lock operation if it already holds a shared lock or write exclusive lock on item X. That means if a transaction only issue the shared lock, then another transaction is applied the shared lock for the same data item. Otherwise, it will be not possible. That means if one transaction issue the exclusive lock, then another transaction cannot hold the shared lock. Now let's consider this example. Let A and B be two accounts that are accessed by transaction T1 and T2. Transaction T1 transfer rupees 50 from account B to account A, while transaction T2 displays the total amount of money in account A and B are defined. If we execute this transaction serially, then after complete this transaction, the display of A plus B will be 300. But if we use this transaction concurrently, then the display of A plus B will be 250. That will be for the schedule 1. Here what happened? T1 lock exclusive for the item B. Then read B, apply B is equal to B minus 50, write B, unlock B. Okay, that means at first T1 issue the exclusive lock for the item B. Since there will be no any such things, so concurrency control manager grant this lock, and after performing the operation B is equal to B minus 50, it will be written in B and unlock B. That means T1 is completed the lock for exclusive lock for the item B. Now T2 operate. T2 at first issue the shared lock for the item A. Since there will be no any such lock for item A, so that will be granted. Read the value of A, unlock A. So that will be completed. Again lock SB. Again T2 issue the lock shared lock for the item B. Read the value of B and unlock B and display A plus B. Since B is already 50 deduction from the T1, so that total will be 250 rather than it will be maybe 300. After complete T2, T1 what happened? T1 again issue the exclusive lock for the item A, then read the value of A and add 50 and write it and unlock these things. So ultimately the result of A plus B should be 300, but we get in 250. So there is a problem for concurrent the scheduling T1 and T2. Now how to overcome this problem? We have some things that will be known as compatibility of locks. Compatibility of locks means suppose that there are A and B, two different locking modes. If a transaction T1 requests a lock of mode A on item Q, on which transaction T2 currently hold a lock of mode B, If transaction T1 can be granted lock in spite of the presence of the mode B lock, then we say mode A is compatible with mode B. So here is a table. The table shows that S stands for shared and X stands for exclusive. So shared and shared true, that means shared and shared are the compatible. Shared and exclusive not compatible. Exclusive and shared not compatible, and exclusive not compatible. Now so again we try to overcome the problem whatever we face in the last example. So here the result of A plus B, the original result will be 300 but we get 250. To overcome this, we just rewrite the schedule in such a way so that the result will be always accurate or consistent. Now in this case, T1 issued the exclusive lock for the item B, then read B. Since T1 exclusive lock, there will be no such any lock for item B. So concurrency control manager grant this lock. T1 read the value B is equal to B minus 50 and write B. Okay. So the 50 is deducted from the B. Now T2 issue the lock, shared lock for the item A. Since there will be no any lock, so that will be granted by the concurrency control manager and read A. Now T2 again issue the shared lock for item B. Since T1 is already hold the exclusive lock, that will be not compatible with the shared lock. So concurrency control manager is waited. Concurrency control manager do wait and T2 is waiting to execute the performance since concurrency control manager give its wait. After this thing, so that there will be no any display because that will be in the waiting stage. Now if T2 does not unlock the A is here, that means it will be holding the shared lock for the item A. Now if we T1 start the exclusive lock for the item A, that will be again wait. Thus T1 is in waiting condition as T2 holds the sharing lock for the item A. If we write unlock A, that means that T1 is unlocked the T2 is unlocked the shared lock for the item A and that will be complete, and here T1 can be issue the exclusive lock for the item A. A is equal to A plus 50 and whatever the value of write A and unlock B and A. After this completion of T1, then this shared lock for the T2, shared lock for the item B of T2, thus that waiting stage is over and that will be performed and we get the result 300 as A plus B. In the last example, if this unlock of A does not written here, that means T2 is hold the shared lock for the item A and whenever T1 want to issue the exclusive lock for the item A, it will be waiting. Again, since T1 is issued the exclusive lock for the item B and T2 wants the shared lock for the item B, so that will be waiting. So in this case there will be the situation that all the T1 and T2 are waiting for each other to complete the lock, and this situation is known as starvation. So how we solve this starvation situation? Uh, there will be some approach. First, if a shared lock is requested, the queue of request is empty and the object is not currently locked in exclusive mode. The lock manager grants the lock and updates the lock table entry of the for the object. That means if shared lock is requested and the queue of request is empty and the object is not currently locked in the exclusive mode, then the lock manager grants the lock and updates the lock table. If an exclusive lock is requested and no transaction concurrently holds a lock on the object, the lock manager grants the lock and updates the lock table entry. That means if the exclusive lock is requested and no transaction is concurrently holds a lock, then the lock manager grants the lock and updates the lock table entry. Now we just see how the locking procedure is performed in Oracle. There will two instances. The first one is I1 and second is I2 in the SQL command prompt. Log in with by the same username password, and in I1 update EMP set cell is equal to 7000 where employee number 7369. That means in I1 we want to update a employee salary to 7000 whose employee number is 7369, and one row updated in I1. In I2 the second instance update employee set salary is equal to 5000 where employee number is equal to 7369. That means in second instance we want to update the employee by the salary 5000 for the employee number 7369. Since I1 already holds the exclusive lock for the employee number 7369, thus I2 is waiting and that will be hanged. If we write in commit or rollback in the I1, then I1 release the exclusive lock on 76.9 and after some SQL prompt, one row is updated for the I2 second instance. And if we write commit and rollback in the I2, the task complete. Now we see the deadlock situation in Oracle. Suppose there will be two instances, one is I1 and I2, log in with the same username and password. Now in I1 we want to update the salary of the employee whose employee number is 7369 by 7000. So one row updated in I1 and I1 hold the exclusive row lock for 7369. Now I2 want to update the salary of the employee number 7902 as 5000, and this will be updated since I2 hold the exclusive lock for 7902, not for 7369. Now first instance, that is I1, want to update the salary of the employee number 7902 to 7000, that will be waiting. due to hold or exclusive lock issued by the instance I2 for 7902. Similarly, if we want to update the salary of 7369 employee number for rupees 5000, again I2 will be hold due to exclusive lock issued by the I1 instance, and these two are the hold, and this situation is in the deadlock situation. When if we write commit or rollback in the I1, that will be release the exclusive lock 7369, and whenever we write the commit or rollback in I2, that will be release or unlock the um, exclusive lock for the 7902, and by this way we can handle. So thank you for now.